Okay, so, and they don't give us the mass of anything. They need to give the mass of something here.
The object B is 28 pounds.
What is 28 pounds?
The block B, I think. Yeah,
Oh, it was
B
stuff
is
at the
28
top.
pounds.
Okay, so this block over here is 28 pounds.
Yes.
Okay, because that's so MB weight or mass.
Weight. Yeah.
So WB equal 28 pounds. Oh, I don't see it here. So maybe I should go to the problem.
The object B weighs 20.
The object B.
And rest on.
Oh, okay. And the moment inertia of the vertical handle about 0.4, so I sub O equal to 0.12 slug foot square.
That's what I mean is the inertia of some slugs.
But it is what is given to us. So. Is that it? Or an F equals 0.2. Oh yeah, now I see the 15 over here. Okay. All right, so here we go. So, all right. What is the procedure? I mean, you can call it free body, but really it's not free because it's not static. So let me just call it diagram, okay? If you call it free body diagram, it's not a problem at all, okay? Dynamic body diagram, but you can call it free if you want. So they say to neglect the mass of this one. So how many are we gonna have? We're gonna have this bar over here, no? Or A if you want, and this block over here, no? So if you do the free body diagram, we have this one over here equal to this one over here, and then we're gonna have this block over here equal to this block over here. So let me keep this one attached over here. Okay, so if we look at the bar, let's first look at the easy stuff. What are the forces being applied to it? The force F, that one, let's start by the easy one, at 15. Then what else? Correct, since they say it's not mass, we're gonna say this is our point A, and we're gonna put this one going in that direction here. Let's call it T, okay? So we call it tension. Good question, but let me answer after we do this one, okay? Now, they don't give you the weight. So if they don't give you the weight, they are forcing you in the way that you have to solve it. So basically, I think we kind of discussed that the other day very quick. What type of motion is this bar having? Okay, very good, your figure. But if it's only rotation, it's about which point? About point O, okay? So let me just go to the next page here and just say something. Probably gonna scratch this page. But basically, let's say we have this bar over here, right? So this bar over here, if you look at this bar about point O, this one we only have here about point O. The only motion of this bar is rotation. But if you look from, and that's because now, what are you doing? You have here the ICG. Remember, you take the moments equal to what? So measure of moments equal to what? I or alpha. You need to take the moments, no? Okay. And then in this case, what are you doing? You are moving all the effects that are happening at the CG. You are moving them to point O. All right. What are the effects happening at the CG? I mean, yes, you will have translation and rotation if you look from there, because you will have translation MAX, MAY, and I CG alpha, no? Yeah? Agree with this? So if we only look at the motion of the bar from point O, then this equation will satisfy everything. If we use the top one, then we need to use summation of forces equals to MA, X and Y, and summation of moments about the CG equal to ICG alpha.
Using the top one's not wrong, just easier to use the one above.
It's a lot less equation, and in this case, since they don't give you the mass, because if you do it this way, you need to have the mass of the bar. If you do it this way, you're not required to have the mass of the bar because they give you the isotope. Okay. Basically, they're trying to force you to do this. All right. So now that this is explained, then, since this is only rotation, what would be the only inertia effect you're gonna have over here? I sub O alpha. And I call this one, this is no alpha for the other one, so let's just call this one alpha. We don't need, I don't think there's another alpha. Oh, it's fine. Now, what about this one over here? What about block B over here? So we have a tension force that should be same magnitude, opposite in direction to the other one, no? Then what else? The weight, the normal force, perfect. So I should have done it before. Can I do it here, the normal force? And what else? Friction, in which direction you want to do it? They say no friction? Free surface, no friction.
And don't say coefficient of friction, so.
You don't need it because you can keep it as an unknown. But they say no friction, no?
Yeah.
Okay, so smooth surface. Let's say here no friction. Okay, so what would be the motion of this one then? MB A sub B, no? Maybe we can do the angle now, or you can do it. I don't know if I want to do the numerical part, but you can probably do it. It's this. We have this. What do we know? This is 6. This is 12. Whatever angle you want, what will be this angle here? How you can find this angle? What will be tangent beta? Maybe, I don't know, but you will be 12 over, so will be 12 over 2, no? Yeah, so it's 2. And this gives you what? 66.43? Oh. 63.43. Okay, you're going to be the one doing the calculations, okay? Not me. Yes. Why we don't? You can include them, but since you take the moments about that point, there will be 0, no? They will create 0 moment. If they were asking in this point to find the reactions, then you would put it. Okay, but good question, okay? So that's it, no? All right, so I think this is always the most difficult part. All right, so step 2 now will be, so let's say a bar, we're gonna call this one bar, this one block. So for the bar, what is the only equation we need to apply? Sum of the moments equal to I sub O alpha. So what will be the equation? Let's start by the easy one. F times 15 without recreating a clockwise or counterclockwise. Positive or negative? Negative, no? Now, what about the t? We can break the t. Only the x component of the t will create a moment, no? So what will be the x component of the t? T sine beta, correct? What will be the arm? I think it was 6, no? See, figures, everything needs to come from the figure. So if it's not good figure, I don't go to the next step. So times 6. Now, with this one, create a clockwise or counterclockwise? Clockwise. So it should be negative again. That's it, no? If you add here the reactions, they will also give a 0, no? Moment. All right, and this should be equal to what? I sub naught alpha. Correct. I sub naught is given to us. 0.12. So this should be our equation 1. Next, we look for the block. So now for the block, what type of motion is the block having? Just translation and just translation on the x. So the summation of forces on the x should be sufficient, no? Because the y, I mean, maybe the y can give us something. There is no friction. Yeah, then maybe there is x direction first. I don't know if it's going to help or not, but since there is one equation, x direction will give us what? Since there is no friction, minus t. No, minus t sine, no, sine, no? Sine beta will be equal to, there is no friction? Okay. Right. And a sub b, okay, I trust you. And the y direction, this should give us what? T cos beta minus m bg plus mb, I guess, yeah. I don't know if mb is going to do anything, but mb is on the figure. No, it's not because it's a tension. Power the tension is going to react something. And this, now this should be really equal to, we can just is equal to 0. Now there's no motion. Well, let's put m and y, okay? Let's see what will happen. I mean, it's 0, but let's put what? What is the acceleration on the y? You want to put m, otherwise we need to differentiate abx and aby, that's why. That's the only reason why I decided not to. So let's say it would be our equation 2. Let's say this would be our equation 3. So now we get to the step that we need to count the number of unknowns. So we got here. So let's say, maybe, we have 3 equations. Unknowns, let's count them. So we have T, alpha, AB, and NB. So it looks like there is 4. Yeah, we know the mass. No, I put it here as we know the weight WB, no? Okay. So, okay. So step 3. Find additional equations from kinematics. So let's see. All right, let me redo a figure here, very quick. Six, 12. Okay, so as we're discussing, the strategy Jan, is to find relation between the accelerations. So let's try to find the acceleration of point A from point O and point B. Okay, so let's do here acceleration of point A from point O will be acceleration of O plus lambda cross S of A to respect to O minus omega square S of A with respect to O. I mean, here, again, I'm pretty sure they don't, I don't know if they say that, but this is probably released from rest. No, initially everything is at rest. So what does that mean? It will be 0. This one is not moving. So we're gonna get over here the acceleration of A equal to I JK 0, 0 alpha. And what is the position of A with respect to O? 0, 6, 0. So this will give you acceleration of A equal to 6 alpha 0. Yeah, the first one is the one that changed sentence. Yeah, I'm thinking ahead. I don't know what it's going to be. So basically that means that acceleration of A equal to minus 6 alpha. And 4. I think that's all we need. Yes, what's your question? And then
Even if it doesn't say that it starts from rest, are we able to generally assume most of
yeah, for these ones, yes. Unless they say otherwise, always assume that they start from rest. Okay. Yes, please. Okay, here what I'm just thinking when I look at this problem is that I wasn't expecting that, but obviously it makes sense now. The acceleration of A is in what direction?
positive X?
Positive X, correct? So you agree that point A and point B, so point B is on the block and the bar as well, no? So what would be the acceleration of point B? The same. Does that make sense or no? They are part of the same block, so really they are the same, no? So we could say over here, let's say since B is in bar AB and the block, I'm just trying to write down, we could say that A sub B equal to A sub A equal to negative 6 alpha, no? So now let's see, is that enough to solve the problem? It should be, so correct. So basically we are here. So maybe let's just write down the equation. So it will be minus 15F minus 60 sine beta equal to I sub naught alpha. We have negative T sine beta equal to M A sub B and T cos beta minus M. I call it this one MBG, but maybe just call it MG. Because otherwise it would be the same, it's the same, these M's are the same, no? I just remove here the B. Or you can add it to the other one, whatever you want to do. Plus MB equal to 0. And then we have acceleration of A equal acceleration of B equal to minus 6 alpha. Again, if you want here, I'm going to put M equal to WB divided by G over here. Okay, so I don't think this equation is needed. So what will be the procedure? Substitute 3 into 2, no? Then you solve for T. You substitute T into 1. Yeah? So let's do that if you want. So what is the first step? Substitute 3, we say, into 2. We're gonna have minus T sin beta equal to minus M 6 alpha, which means that T will be equal to 6 M alpha divided by sin beta. Next, what do? We substitute the T into 1, no? Substitute T into 1. So what do we get then? Minus 15F minus T minus 1. It's fine. Sin beta times 6 equal I sub naught alpha. This is going to give us minus 15F minus what is T? 6 alpha over sin beta times sin beta, no?
6 sin beta.
6 times 6? Oh, really?
It's 6.
Oh, yeah, because it's 6. Okay, I get it. So can I just put 36 here? Equal to I sub O alpha. Okay, it looks here, unless we did something wrong, this is what is happening now. The sin beta will cancel it out. So then we're gonna have here then what? Negative 15F will be equal to alpha factor of I sub naught plus 36 M alpha, a factor of the alpha. 36 M. Oh, yeah, sorry. Yeah, correct. 36 M. There's something wrong here. So basically we get alpha would be equal to negative 15F divided by I sub naught plus 36M.
With everything.
Yeah, what was that? 36? Where is that 6 coming from?
Oh, that's another one. 6 is just another one.
Okay, so that makes sense now. Okay. Because I'm just looking at the units. What should be the units of I sub naught?
Kilograms or meters of force, right?
It will be its mass. So it's slug feet. So this one will be slug. This is the distance. Not the 36 is the distance squared. So this should be an MR square. Okay, I was just looking at the units. No, so units are correct. Or whatever that is. Yeah, that should work. I should work because the 36 is distance, no? I didn't know what the 36 is, so the unity works. Yes.
Whenever we were doing our additional equation, we were able to assume acceleration A and acceleration B were the same. I was just wondering like, how we were able to do that.
Okay, I think we discussed that already, but let's just do it again. No, we discussed it, no, a little bit, but okay, look at it again, okay? Okay. Point A and point B are on the same bar, same element, no? So is it a way that two points on a rigid body move at a different velocity or different acceleration? Okay, they are moving the same. So since point B is also on the block and the bar, it means that the acceleration of the at that point at point B is the same as at point A, no?
So, like,
So does that answer your question or no?
it does.
Okay.
So if block B, even if it was rotating, it still would be the same.
No, that's the problem is that let's say that's what I was expecting, but it did not happen. Let's say acceleration of A here at an X and Y component. Then what would happen here at point B? B, we only have one acceleration on the X, but the magnitude of the acceleration of B should be equal to the magnitude of the component on the X and Y direction at A, no? Do you understand what I'm saying here? Okay. But in this case, since there is no Y component, it's directly equal. If it was here Y component, you would have to do the magnitude at point A, and then the magnitude here should be the same as the magnitude here, no?
Okay, so regardless of magnitude, it's the same. It is-
Regardless, whatever is the X or Y direction, the magnitude at those 2 points should be the same.
Okay, that makes sense. That's what I was-
That's fine.
If we were to solve this, would we need to convert the slugs to pounds so that we have the same terms on the bottom?
Yeah, those units are always in nightmare stuff. So let's see what they did here since slugs, let's say what they did here. Whatever, you want to take the answer? Well, basically they give you the slug so that maybe you don't have to divide the M by just 32.2. Does that make sense or not?
So the final equation for alpha is.
Yeah, that's the expression for the alpha.
Yeah, it's T mass.
Mass, M is mass. But they give you this in slugs. Okay, so I mean, if you want to do it, and that way you figure out the units. If you do this as they are over here now, just do minus 15 times 0.2 divided by whatever is the I 0.12 plus 28 without transforming the units. Oh, you have to transform the units, no? If you deal with this data, it looks like you should get 1.06.
What are they getting that? I don't get 1.6.
Yeah, so guys, so the issue is that either you move this one in inch square, or we need to move this dimension into feet, no? Correct? So then all these ones should be then whatever divided by 12, or I mean, let's leave this one here this way. I just going to put over here, but I sub naught in slug inch square, no? Instead of foot square. But I mean, I'm not going to say now about the numerical part like I told you all the time. You will figure it out, no? The units. What I'm interested is on the procedure, no? So omega AB is 10 radians per second constant. So what does that mean for alpha AB? Zero. Perfect. In the counterclockwise direction, the mass of slender bars BC and CD, so let's say M BC equal MCD equals 2.2 kilograms. Oh, no, sorry, is respectively. So MBC equals 2.2 kilograms. MCD equals 5.4 kilograms. Respectively. Determine the OX component of the force exerted on the bar BC by the pin at that instant, the horizontal. So BY, no? No, the BX. Okay, determine okay, very strange problem, but that's fine. We'll work it out. Okay, so once again, in this problem, they don't give you the mass of AB, no? So what are you gonna have to do then? Find about A, okay? So they're asking anything about point D, and we can do probably the same thing about this one here. We can do probably the same for this one. Okay, probably I'm gonna have to find, all right, yes. All right, let's go. Let's see how far I can get, okay? To help you with this part. 1, 2, 3. All right, so this problem, how many rigid bodies do you have? 3. So you can do it here. AB. I will keep this one pin equal to this. Then we have here AB. We have BC. And we have DC. Yeah, whatever you want to call it. CD is a CD, DC. Okay, so over here. For the first one, we're going to look at the motion of this bar from where? From point A. The motion of this bar is only rotation from point A, no? So this will mean that we'll have over here, maybe let me start here from this end. We're just going to have as motion I sub A alpha AB. No? Okay. Now, what will be the forces being applied to this one? We move the CG to point A, no? So I will eliminate the MAX, MAY. Correct? Okay, if you want then, what will you have over here? you're gonna have here the by, bx, and even if you want here, you can put the mab g. It's not gonna do anything because we're gonna take the moments about point A, no? Okay, the one that's gonna be a nightmare is BC. What are the forces in BC?
BYGX.
Correct, so on the opposite direction will be BX, BY, and then what are you gonna have on the other side? CX, CY. And then what type of motion would this have? MBC, A, how do you want to call this point here? I mean, well, I don't think we're gonna need it if we take the moments from the other one. So you just say AX and MBC, AY. Correct? Okay. Then what are we gonna have here at point C? Oh, I forgot something here. No, it's good. What are we gonna have here at point C? CXCY, but it should be on the opposite direction, no? CXCY. Then what are you gonna have over here? CDG. And I'm keeping this pin, no? I don't remove the pin, okay? Then what are you gonna have over here? Oh, we have the choice. Here we can select to take also the moments about point D. So if we take just about point D, that means we're gonna have here can I call just this one ID? Alpha CD, is that okay? It's just notation, okay? Any question? Oh yeah, and then we need all the kinematics. So I want to see if I can do it. The trick to do these ones is that when you have all the equations, go to MATLAB or software that will solve the equations for you, okay? I'm not testing you in solving a system of whatever, 6, 7 equations unknowns, no? All right? I'm testing you finding the equation. So step 2 is to do what? Find the kinetic equations. So basically, let's say AB. What will be the equation of AB? You have the figure here. So this one, what type of motion is it having? Just so rotation. We could use summation of moments about point A equal I sub A alpha AB. Counterclockwise. Okay, so that's 0. Okay, so yes, what can I say? I didn't see that one, but I guess it's so. But let's say we are over here. The equation will be basically bx times what? 0.2, no? What do we need to find bx?
There's on BX, BY, CXCY.
Well, but it's only asking for BX. Yeah, but BX.
Yeah, but if we do this, so but if now you say that this is equal to 0, then is bx equal to 0? Something strange here. Alpha AB is 0, no? Okay, so let's say this one is, this is 0. So let's say this is our equation 1. Okay, whatever that is, we try to keep going. This is not going to give us any useful information. Okay, so now bar BC. What type of motion is that one having? Translation and rotation, no? So we're going to do summation of forces on the x direction. So let's say summation of forces equals to MA. So x direction will give us what? Minus BX plus CX will be equal to MBC AX. Equation 2. Okay, y direction will give us what? Minus BY minus MBCG plus CY equal to MBC AY. Equation 3. Really, the first equation is not giving us anything. But again, so I put it there. And then here, let's say you take the moments about which point? But think about the CG. It's probably going to be easier or less risky. I mean, you can move it to a point if you want, but you think about the CG, then what do you have here? So let's see, you think about the CG, BY and CY will be creating moment on the same direction, no? So we could put here BY plus CY times, what is 0.1? Half the length of the bar.
Aren't BY and CY going in the same direction in the bar?
No, but they will create a moment on the same direction, which go counterclockwise. No? Yeah. So that's it, no? And this should be equal to ICG alpha. This will be of what? Alpha of the bar BC. So we need to add BC over here. Alpha BC. Yes. 3. And finally, we're going to look at the bar CD. So bar CD, we decided to take the moment about point D, no? So we take moment about point D equal to ID alpha CD. And take clockwise positive. When is this assignment due? The Thursday after the break, no?
Tuesday.
Tuesday, okay, I'm going to move it to Thursday. All right. So basically, what would be that equation here? So let's see. So we'll have then CX times, I'm just going to do symbolically length of CD that you can calculate times what? So let's say it will be CD LCD. This is, oh, we don't need that. We don't need that. It's easier to do. Yeah, but we don't need to do that. This is 0.2 and 0.2, no? So we could do, sorry, we could do CX times what? CX is going on the left, so it's going to make a counterclockwise moment. So CX times 0.2. Yeah? Wait, you don't see it on the figure, but it's hard for me to look. Here we go. So CX times 0.2 going counterclockwise, and then CY is also going to go counterclockwise, no? Plus CY 0.2 equals to I sub D alpha CD. about point D.
Right.
This should be equation 4. I know I'm just rushing a little bit, but so I want to make sure I make two things. The next step, because I don't think that's something we have covered. At least I do not remember. Correct. That's what I'm going to do next. Okay. So here, if you want note, that's going to put here note. I change the color. All right. So from the books, or generally what will be given to you is that the moment of inertia of a bar about the CG of the bar is given by m s squared divided by 12. Okay. If you want to find about, let's call the edges, let me call P instead of A or B. Okay. All right. So if we want to move this one to the ends, what do we use? We use the parallel axis seller, no? Which will be what? ICG plus M D squared. So this will give us what? M S squared over 12 plus M. What is the distance we want to move it? D, which is L over 2, no? Okay. So now if you do this, you find out this is ML squared factor of 112 plus 1/4, which is going to give you that I sub P about the end to be ML squared (3). Okay, so all this stuff is to say what? Here I call it I sub P, but what is I sub D? I sub D would be M, how do we call it? CD, no? MCD, length of the bar CD square, divided by 3, no? Yeah. Then what will be, so this will be ID. We don't need this one because it's 0. What will be ICG over here in the equations? Would be MBC LBC squared divided by 12, no? Okay. If you want, or you can just plug them, yes. I mean, if you count, that's what I want to say. If you count them as unknowns, then you need to put this as equations, okay? But if you say that you know them or you put them as initial data, you don't have to put them. Okay, so basically we get here. So we get to this point, and now we need to do the step of, let's say we have, whatever, it's 4 equations, but really it's only 3 equations, okay? Let's say what will be the unknowns that we have. So let's say Bx, By, Cx, Cy, Ax, Ay, alpha Bc, alpha Cd. Am I forgetting anything? I'm not counting the first one. So Bx, Cx, Ax, By, Ay, ICG, alpha BC. I think that's about it, no? So it's 1, 2, 3, 4, 5, 6, 7, 8. And really, I would say 3 equations. Let's be honest, okay? First equation doesn't give us anything. But it doesn't give anything, the first equation, basically. So basically what I'm trying to say is that we need additional 5 equations. So from where are you going to get the equations? From kinematics. So we're not going to have the time to do that, but I'm probably going to have the time to tell you what to do. That probably we're gonna be able to do that stuff. So here is gonna be even more tedious than Johnny, what you do. So what are we gonna be able to do over here?
Get a solution from A and C.
Okay, so we're gonna get the acceleration of B from point A. Will be A of A, but it basically will give us 0, no, again. But again, will be plus alpha AB cross, I know because omega AB is not 0 here. Alpha B S of B with respect to A minus omega square AB S of B with respect to A, no? So I'm not going to do that. We can do it quick. This is 0, this is 0. So very quick. We can find over here that A sub B will be equal to what? Minus, what do they say? 10 squared. What is the position of B with respect to A? 0.2. So basically, I'm going to do this very quick. You get A sub B will be equal to whatever, 0 and 20, no? Negative 20. Okay, now it's going to be a nightmare. I mean, it's a lot of calculations. What are you going to do? You're going to find the acceleration of C from point B, no? So you'll find acceleration of B, plus alpha CD cross S of
CD or C?
acceleration of C with respect to B. So it should be BC, you're correct. Alpha BC, going too fast, S of C with respect to D, minus omega square, I forgot something, BC, S of C with respect to D. So, okay, I'm going to keep going, and then I'm going to explain, you're going to write this equation. Then what can we do? We can write down the velocity, the acceleration of C from where? From point D. We'll give you A sub D plus alpha CD cross S of C with respect to B. This would be C with respect to B here. C with respect to B here, not D. Okay, the previous equation, sorry. S plus minus omega squared CD S of C with respect to D. Okay, bad news. I forgot to do something before. We don't know the omegas. So in order to find for the omegas, what do we need to do? We need to first find the velocity equation. So here we go. So can I just explain what needs to be done, or you want me to write down the equations? I mean, let's write down the equation. We have time. We write down the velocity of B from point A, VA plus omega AB cross S of B with respect to A will give us what? JK 0010 0.20 will give us velocity of B equal to -2, -20. Then you find velocity of C from point B, VB plus omega BC cross S of C with respect to B. And you take VC from point D, VD plus omega CD cross S of C with respect to D. And I'm going fast, but I'm just trying to. You take these two equations and you solve for what? Omega BC and omega CD. All right. Now that you have these ones, what can you do with these two equations? Solve for alpha BC and alpha CD, but you first need to do this step, no? Yes? Okay. First, second. All right. But now you don't need AC or AB. What do you need? You need the acceleration of which point? at the CG over here, no? Yes? Which is really what we call here AX, AY. So now you can calculate the acceleration at this point from either point B or point C, no? Yeah? So you're able to calculate the acceleration of point C from point D. Let's say this will be 0, no? Okay. So now you calculate here, let's say from point, from point B. So it'll be equal to AB plus alpha BC cross S of CG with respect to B minus omega squared BC S of CG with respect to B. So this will give you here, this one over here will give you two equations. AX and AY. Then I guess from here you're going to find one equation for that's going to relate alpha. Well, here is going to give you two equations now. And this is actually the fifth equation that, so maybe it's four equations. I will have to work it out, okay? So maybe here if we set up three, we have but four, as you said. We have eight unknowns, but we have 8 equations now, no? Do you guys follow the procedure?
With the two angular velocities, two unknowns.
Correct. So will be the angular velocity. No, we already counted the angular accelerations as unknowns. The velocities you see, I did not count in this equation, these two equations.
Okay.
No, I pay attention to that. But I mean, I will have to do it to see exactly what are the unknowns and the equations. But basically, I'm sure that if you do this, you're probably going to get enough equations, okay? So what I suggest is that no matter what, you write down the equations, you go to MATLAB or Maple or whatever you want and solve this system of equations. Don't even try to do it by hand, okay? So probably on the Tuesday after the break, we do one of these ones with the MATLAB. All right, so have a good break.